Today I have a very interesting problem for you. I heard it when I was 11 or 12 and I thought it was impossible to solve. I had this very nice puzzle book. But it is not that difficult after all. The problem says that there's a box with some candies. We don't know how many candies are there, but we do know this. If you take them out 3 at a time, 3, 3, 3, then eventually 1 will remain. If you take them out 4 at a time, 4, 4, 4, then 2 will remain. And if you take them out 5 at a time, 5, 5, 5, then 3 will remain. What is the minimum number of candies that can be in the box? Before you try to solve this problem, rather before you listen to the solution of the problem, pause the video, try to solve it for some time, and then listen to the solution. Alright, hopefully you've paused the video and attempted the problem. Now here's the solution. So we know that when we take them out 3 at a time, 1 will remain. So it can be either 3 plus 1, 4, or 3 into 2, 6 plus 1, 7, or 3 into 3, 9 plus 1, 10, or 3 into 4, 12 plus 1, 13, or 16, or 19, or 22, and so on. Another very important point that we know is that when we take them out 4 at a time, 2 will remain. So it can be either 6, or 10, or 14, or 18, and so on. This gives us a very important factor though. An important fact though. Number of candies in the box definitely will be even. Because when you take them out 4 at a time, 2 will remain. So it's either 6, 10, 14, 18, 22. But it definitely will be an even number. Now, we also know one more thing. When you take it out 5 at a time, 3 will remain. So it's either what? 8 or 13, 5 into 2 plus 3, or 18, or 23, or 28, or 33, or 38, or 43, or 48, or 53, or 58, or 63, or 68, and so on. Because all these numbers, when you take them out 5 at a time, 3 will remain. However, we learned a very important fact that when you take them out, that the number of candies has to be even. We learned it from this fact. Therefore, these cannot be the possibilities, all the odd numbers. So the number of candies is what? 8 or 18 or 28 or 38 or 48 or 58 or 68 or 78 and so on. So we know that the last digit is definitely 8. Now let's try each and every number and see if any of these numbers, which is the smallest number among all these, will satisfy the above two conditions also. So let's say 8. Does 8 satisfy this condition? No. When you take them out 4 at a time, 2 should remain. But 8 is perfectly divisible by 4, so 8 cannot be possible. 18. 4 4s are 16 and 2 is remaining. So it is satisfying this condition. But we also know that the other condition was that when you take them out 3 at a time, 1 should remain. But with 18, this is not the case. Because 18 is perfectly divisible by 3. So if there were 18 candies and you were taking them out 3 at a time, 0 would have remained, which is not what we want. So 18 cannot be the possibility. 28, perfectly divisible by 4, not possible. 38, 4 9 are 36 plus 2. So this 38 satisfies this condition. But if 38 candies were there and you were taking them out 3 at a time, 2 will remain. But this is not what we want. Only 1 should remain when you take them out 3 at a time. So 38 cannot be possible. 48 is perfectly divisible by 4. 58. When you take them out 4 at a time, 4 14s are 56. So 2 is remaining. So 58 is satisfying this condition. When you take them out 3 at a time, 1 is remaining. 1 should remain. So 19 3s are 57 and plus 1. 58. So 58 is satisfying the condition of 3 also. So since all these numbers were satisfying the condition for 5, but 58 is the smallest number among all these, which is satisfying the condition for 3 and 4 also. Therefore 58 is the answer that we were looking for. And our answer is 58.